In this video, we're going to discuss a specific kind of sequence called a recursive sequence. And a recursive sequence is a sequence in which the terms are defined using one or more previous terms. And the notation for a recursive sequence, it will look like this. Well, the first thing it will do is it will give you at least the first term. For example, it will say A1 is 3. And then it will give you the general or the nth term of the sequence. But what will happen is when it defines that nth term, it will use the previous terms in the sequence. So it might say 2 times A n minus 1. So you must use the n minus 1 term in order to find the nth term. So if I want to define for this example A2, I'm going to plug in, everywhere I see n, I'm going to plug in 2, so that would give me 2 times A, and then n would be 2, so I would have the 2 minus 1 term, which would be 2 times, and then 2 minus 1 is A1. So I'm using the previous term. I'm using the first term to find the second term. So I'm going to take A1, which is 3, and multiply it by 2. So the second term is 6. Then if I wanted to find the third term, I would plug in 3 for n. So I would have 2 times A sub 3 minus 1, which would be 2 times A2. So to find A3, I'm going to use the second term. The second term is 6. We just found that. So I'm going to take 2 times 6, and I'm going to get that my third term is 12. So if we continue to go on, you can see that the pattern is you take 2 times the previous term. That's this specific example. Now, let's look at example 1. It says we're going to list the first 5 terms of the sequence. Okay, they tell us that A1 is 7. That's given to us. And with the recursive sequence, they have to give us, the author of the question has to give us at least the first term. Sometimes there's more than one term used. Okay, so then to find A2, we're going to use the nth term because A2 was not given to us. So to find A2, I'm going to take A 2 minus 1 plus n, and n in this case is 2. A2 minus 1 is A1, and I add 2. So I'm going to take 7 and 2, and I'm going to get 9. For A3, I'm going to plug in 3 for n. So I have A, 3 minus 1, plus n, which is 3. 3 minus 1 is 2, so I'm going to take A2 plus 3. Well, A2 we just found was 9, so I'm going to take 9 plus 3, and that's going to give me 12. For A4, I'm going to plug in 4 for n. So I have A, 4 minus 1 plus 4. 4 minus 1 is 3, and A3 we just found is 12. So I'm going to take 12 plus 4, and I'm going to get 16 for A4. And then for the last term, I'm going to plug in 5 for n. So I have A, 5 minus 1 plus 5. 5 minus 1 is 4, so I'm going to find A4 plus 5. A4 is 16, so 16 plus 5 is going to give me 21. So A2 was defined by A1, A3 was defined by A2, so we keep using the previous term in order to get the next term. And that's exactly what a recursive sequence is. when you use previous terms, at least one, maybe more, to define future terms. Okay, so in this example, again, we're going to find the first 5 terms. A1 is given to us. It says A1 is 2. So we're going to find A2 now. So everywhere I see n in my nth term formula, I'm going to plug in 2. So I have -2 times a to the 2 minus 1, which would be -2 times a1. Well, -2 times a1, we said a1 is 2, so that's going to give me a -4. A3, I'm going to take -2 times a, 3 minus 1. 3 minus 1 is 2, so I'm going to take -2 times a2. And -2 times a2, since a2 is -4, I'm going to have -2 times -4, which is +8. A4 means I'm going to plug in 4 for n now, so I have -2 times a, 4 minus 1, which means I'm going to take -2 times a3. A3 is 8, so I'm going to take 8 times -2, which is -24. Okay, last one that we have to find, because it says find the first 5 terms. I'm going to take -2 times a, 5 minus 1, which is -2 times a4. A4 is -24, and when I multiply it by -2, that gives me a +48. In example 3, it says find the first 6 terms of the sequence. Now in this example, we use 2 previous values. We use A1 and A2. So we're given that A1 is -2 and that A2 is +5. And we want to find A3, A4, A5, and A6. So everywhere in my recursive sequence for my nth term that I see n, I'm going to replace it with 3. So I have a, 3 minus 2, times 3 minus a, 3 minus 1. So this is going to give me a, 3 minus 2 is a1, times 3 minus a, 3 minus 1 is a2. So I'm going to take a1 times 3 minus a2. a2 is 5. So I have a1 times 3 minus 5 is a -2, and a1 is -2. So I have -2 times -2, which is +4. Now let's do a4. A4 says I'm going to take a, 4 minus 2, which is a2, times 3 minus 4 minus 1, which is a3. Well, a2 is 5, and I take 3 minus a3. A3 is 4, so I take 3 minus 4 inside the parentheses. That gives me a -1, and then 5 times -1 is -5. A5 now, I'm going to plug in 5 everywhere I see n. So I have a, 5 minus 2, which is a3, then 3 minus a, n minus 1, since n is 5, it's going to be a4. So I have a3, which we found was 4, times 3 minus a4. A4 we found was -5, so I have 3 minus a -5, which gives me 8, because that double negative turns it into a positive, and I get 4 times 8, which is 32. Last one, A6. I'm going to plug in 6 for n, so I have a, 6 minus 2, which is a4, times 3 minus a, 6 minus 1, which is a5. A4 we said was -5. A5 we said was 32. So I'm going to have 3 minus 32 on the inside of the parentheses, which is -29. And when I take -29 times -5, that's going to give me a positive 145. In example 4, we're going to talk about a very famous sequence called the Fibonacci sequence, and you may have heard of it before. And the Fibonacci sequence is a recursive sequence. And the recursive sequence is defined as A1, the first term is 1, the second term is 1, and the nth term would be where you take the two previous terms and add them together. So we would start off by saying the first term is 1, the second term is 1, and then to get the third term, you would add the first two together. So that would give me 2. To get the fourth term, I add the previous two together. So if I take 1 and 2, I get 3. Then to get the fifth term, I would add the previous 2. So I would get 5. And then I would get 8. And then 13, etc. So to get the next term, you add the previous 2. And the Fibonacci sequence is very famous, and it has a lot of scientific applications, and it is seen a lot in nature and in music. And it's defined as a recursive sequence because you need the previous 2 to get the next term.